So let's say we want to find the integral of dx over root x, open bracket, root x plus 7. Now to do this we need to use substitution method, and by substitution we can say let x be equal to a particular alphabet, let's say t, but since x is inside the square root sign, I will prefer to say let it be t squared, so that root x will become the root of t squared, so that will be t. Okay, now it will mean that if I differentiate x, I'll have dx. If I differentiate 2t, I will have 2t dt. Okay, now that is, for every time you differentiate, you put it. When I differentiated x, I had 1, that is 1 dot dx, which is the same thing as dx. Then if I differentiate t squared, I will have 2t. Then I just need to attach dt to it to show that I have differentiated it. So that will be 2t dt. So substitute, if I have c dx in the expression, I substitute it with what? 2t dt upon root x. Root x is the same thing as t, don't forget, t, then t plus 7. So I have something of this nature now. T can cancel out with t, and 2 can come out of the integral sign, so that I have dt upon t plus 7. So what is the integral of dt over t plus 7? That's supposed to be 2 ln t plus 7 plus c. The reason is because for every time, one of the laws of integration is that if I have if I have the derivative of a function and I have the original function at the denominator, the answer is the ln of the original, which is at the denominator. Okay, what I'm trying to say is that for this particular problem, we had dt at the top, isn't it? And then what we have at the denominator is t plus 7. If you look at it very well, if you differentiate t plus 7, you will have dt. That's just what you will have, because if you differentiate t, that is dt. If you differentiate 7, that's 0. So what you will have is dt, or you can simply say what you will have is 1 times dt. Okay, so it's the same thing as what? Ln of the denominator. It's just a law, and that is why whenever we want to integrate 1 over x, just like we have it in this law right here, look at it. Okay, just like if you want to integrate 1 over x dx, the answer is equal to ln x, and the reason is because if I differentiate x, I will have dx, or you can say if I differentiate x, I will have 1 times dx, or 1. Okay, that will be ln of the denominator. The same rule is applicable to the integral of sine x over cos x. Okay, if you look at it intently, you will see that if you differentiate sine, if you differentiate cos, which is the denominator, you will have negative sine. Okay, that means what is at the top is the derivative of what is at the denominator, but it's not a little bit balanced, simply because I need to apply negative sign, negative to it. Okay, because if I differentiate cos, what I will have is negative sign, so it's balanced this way. But because by attaching this negative sign, I have simply changed the question, so I need to balance it by applying another negative sign right here, so I will make it minus 1. Okay, now if I differentiate cos, I will have minus sign. According to this law, it satisfies it, and that's why I will have 1 over minus 1, then what? Ln of the denominator, which is the cos x, ln of cos x. Okay, and that's why the answer is minus ln cos x. Okay, and that's what I have right here for tan. That's what I have right here, minus ln cos x. Okay, so let's return to the original question. So don't forget that ln, t is actually root x, so I will have root x plus 7 plus c, which is the final answer. Okay, so that's the final answer. Now let's solve another problem. Now let's say we want to find the integral of 1 over exponential x plus 9 exponential minus x. So I need to use substitution. So I can say let u be equal to exponential x. If u is equal to exponential x, or it is the same thing as exponential x equal to u. So if I differentiate both sides, exponential x dx, anytime you differentiate exponential x, it repeats itself. If I differentiate u, that will be 1 then du. Okay, that means dx is equal to what? Is equal to du over exponential x. So I can substitute now into integral of exponential x is now u plus 9 u raised to power minus 1. Okay, but if you don't want to go with that, we may first of all simplify the question by having it as 1 over, by simply we may simplify it, since exponential x plus exponential minus x means 1 over exponential x. So I can simplify it. So that it becomes, if I find the LCM of the denominator, I will have exponential 2x plus 9 over exponential x. So it is just like having 1 divided by exponential x upon exponential 2x plus 9. So what I really want to integrate is the integral of exponential x upon exponential 2x plus 9. Then I'll have the x beside it. Okay, but now I have substituted exponential x as u, so I will have the integral of u upon u squared plus 9. Then instead of having the x right here, I will substitute the x as what? As du upon, don't forget that from this point du upon, since exponential x has been substituted as u, I can replace it here as u. So this is u, so u can cancel out with u. So the question has been reduced to what? Du upon u squared plus 9. Now you need to note that if you integrate some functions such as 1 over x squared plus x squared, you will have 1 over a, then arctan of x over a. Okay, x over a plus c. That's what you will have. All right, now let's say you now have another function such as this 1 over root of a squared. These are just standard forms, standard integral. 1 over a squared minus x squared, that will be 1 over a, then arc sine of x over a plus c. Also, if you may have 1 over x root x squared minus a squared, that will be 1 over a arc sec, okay, of what? Of x over a, then plus c. In my video with the topic differentiation of function, I explained how that the derivative of arctan and all of this will be equal to this. It will be very helpful if you can actually watch that too. So looking at this particular integral, that is the integral of u squared, the integral of du upon u squared plus 9. 9 is the same thing as 3 squared. So I can simply have it as 1 over 3 using this standard integral. I can say a is now 3, isn't it? I can have it as 1 over 3, then arctan of x of u upon 3, then plus c. But what is u? What is u? Okay, what is u? U is actually exponential x, so that I will have exponential x over 3 plus c. Final answer. Let's solve another problem. Water is flowing through a tank at the rate of root 3t plus 1 feet cube per minute. If the tank is empty when t equals to 0, how much water does it contain 5 minutes later? So rate means that something is changing with respect to time. So for this case, the volume of water is changing with respect to time, and the rate at which it is changing, which is dv dt, is given as 3t plus 1, which means that dv is equal to root 3t plus 1, and of course dt. If I integrate both sides, I'll have v right here, then I have the integral of 3t plus 1 dt to integrate square root. Okay, to integrate something of this nature, I can say let w be equal to, let w square be equal to 3t plus 1, so that 2w dw will be equal to 3t dt. Okay, if you differentiate w squared, you will have 2w. You can check my video where I talk about differentiation. So I need to make dt the subject of the formula. So 2w dw equals to 3t dt is the same thing as 3t dt equal to 2w dw. So dt is equal to 2w dw upon 3t if I divide both sides by 3t. So I can go on now. V is equal to the integral of root w squared. So instead of having dt, I will have what? 2w dw upon 3t. Never, never. It's not. Oh, there's a mistake. There's a mistake now, because if I differentiate 3t, I'm supposed to have 3, not 3t again. So I shouldn't have this. So I will just have to divide both sides by 3. So I should have something of this nature. Alright, that's it. So I can bring out the constants. Now remember that the square root should cancel out the square, and of course we can bring out the constant, which is 2 over 3, and then we will be left with integral and w with another w, that's w squared dw. If I integrate that, I will have w cube upon 3 plus c. But remember, what is w? That's 2 over 3 times 3, which is 9. W raised to power 3. W is root. Remember, if w squared is equal to 3t plus 1, it means that w is root 3t plus 1. So we have 3t plus 1 to be raised to power of 3. So okay, so that's our v right there. So plus c, so it means that v is equal to 2 over 9 root 3t plus 1 raised to power 3 plus c. That's the v, that's the original value of the volume of that particular tank. Okay, now the question continues by saying if the tank is empty, that means at v equal to 0, that is when the volume is equal to 0, the question says that t is also equal to 0. Okay, now let's see what will happen at that scenario. V equals to 0, 2 over 9, then I have the root of 3 into 0 plus 1 cube plus c, which means that 0 is equal to 2 over 9, then the root of 3 times 0 is 0, that's the root of 1 raised to power 3 over 9, and of course that will be equal to 0 equals to 2 over 9, which is plus c. That means if I take 2 over 9 to the other side of the equation, that means c will be equal to 0 minus 2 over 9, which is equal to negative 2 over 9. That means the real value of v is equal to 2 over 9 root 3t plus 1. okay, minus, we are supposed to have plus c, but now our c is 2 over 9. So this is the value of the volume. Now the question is, how much water does it contain after 5 minutes? All right, so let me get rid of this space now. So at 5 minutes the v will now be equal to 2 over 9, then root 3 into 5 plus 1, 3 minus 2 over 9. We didn't bother converting because we are dealing with minutes from the question. So v is equal to, that's 2 over 9, then the square root of 15, that's supposed to be square root of 15. 5 times 3, 15 plus 1, that's the square root of 16 raised to power 3 minus 2 over 9. If you press this directly on your calculator, you have the right answer, but let me just boil it down a little bit. The square root of 16 is 4, and of course 4 raised to power 3 is 64, okay, minus 2 over 9, and of course 2 times 64 is 128 over 9 minus 2 over 9. If you press this directly on your calculator, you will arrive at 14, that is 14 feet per minute, 14 feet cube per minute. That's option D, very correct. Okay, if d squared s dt squared is equal to 2t minus 7, find s in terms of t. Okay, now if there are some conditional statements, if t is equal to 0, s equal to 0, and then ds dt is equal to 6. Now let's see how we can go around this. Now I told you in one of those videos earlier on that if you differentiate s, you will have ds dt. If you differentiate ds dt again, you will have d square s dt squared. So for you to return to s all the way from d square s dt square, you need to integrate first, then you need to integrate again. So we need to integrate twice. If I integrate this first equation, I will have ds dt to be equal to 2t squared over 2, okay, minus 7t plus c. Okay, now the condition states that at t equal to 0, every time you integrate, you apply the condition so that you can know the value of the constant c. At t equal to 0, s equal to 0, and ds dt equal to 6. ds dt equal to 6. If I apply that, I will have 6 equal to 0 minus 0 plus c, because substituting t into 2t squared, that will be 0. Substituting t into minus 7t, that will be 0. It means that c is equal to 6. That means ds dt is actually equal to 2t squared over 2 minus 7t plus c, where c is 6. This is the original ds dt. Now we need to integrate again to obtain our s originally. So if I integrate ds dt, I will have s. Notice that these two can cancel out so that we can have t squared, and of course if I integrate t squared, that will be t cubed over 3 minus 7t squared over 2. Okay, 7t squared over 2 plus, if I integrate 6, that will be 6t then plus c. Then we need to apply the conditions again so that we can obtain c. So the question says at t equal to 0, s equal to 0. So s is now 0, t is 0, minus 0 plus 0 plus c. So it means that c is equal to 0. So originally we will now have s to be equal to t raised to power 3 upon 3 minus 7t squared upon 2 plus what? 6t plus c, where c is 0. So we may not need to write this plus 0. So finally, this is the original function x, and that's the right answer for that question. Okay, now let's say we want to find the integral of sine x over 1 plus cos squared x. The only relation we could think of is, we had a squared plus x squared as part of the functions that we have in the standard integral. That is, the integral of 1 over a squared plus x squared is equal to 1 over a, then arctan of x over a. But if a is 1, that will be integral of 1 plus x squared. That will be arctan of x, then plus c. So looking at this, we could think of something of that nature. And if that will be possible, it will mean that I can say let u be equal to cos x, so that if u is equal to cos x, I'll have something of this nature. I'll have sine x upon 1 plus u squared. So I should find a way whereby sine x will cancel out, and of course it will cancel out if I differentiate u. So if I find du dx, that will be minus sine x then dx. Okay, so divide both sides by minus sine x so that dx will be the subject of the formula. Okay, and then I'll have dx to be equal to du upon minus sine x. So the question will become sine x upon 1 plus u squared. So instead of having dx, I'll have du upon negative sine x. So sine x can cancel out sine x. Negative sign can go out of the integral, so that I can have du upon 1 plus u squared. So the integral of 1 over 1 plus u squared is arctan of u plus c. But what is u? U is cos x. So that is the final answer. Okay, let's solve the next problem and the last problem. So let's say we want to find the integral of sine x over 1 minus sine squared x plus sine 2x over sine x dx. Okay, I'll choose to do this separately by doing this, then sine x upon, okay, before we do that, the last example before this, we had something of this nature, but the difference is that the last question had positive sign right here, but this had negative sign. So because it had positive sign, we used the arctan integral. Okay, now how about this with the negative sign? There is no other term that we can relate with as for this particular question in the standard integral. So one of the things we can do about this denominator is to change it, because it looks like something of this nature in trigonometry. Okay, because according to the first trigonometry identity, sine squared x plus cos squared x is equal to 1. So if I make cos squared x the subject of the formula, cos squared x will be equal to 1 minus sine squared x. So anytime I see 1 minus sine squared x, I can still replace it by cos squared x. So let's see cos squared x. Then sine 2x is from the double angle formula. Sine 2x is equal to 2 sine x cos x, and it all started from the compound angle formula, which is sine into x plus y. If I have sine into x plus y, it will be sine x cos y plus cos x then sine y. But when we talk about double angle, we are talking about x and x. So x and x, that will be sine x cos x plus cos x then sine y. they are sine x, they are now the same, they can add each other so that it is sine x cos x. And of course this is the same thing as sine 2x, because x plus x is 2x. So anytime I see sine 2x, I can always replace it by what? By 2 sine x cos x, then upon sine x. And of course we can cancel out sine, okay, and this is with respect to x, it is all with respect to x. I can do the integral separately since it is separated by a sign. All right, so if I have something of this nature, this can be reduced to what? To 2 cos x dx, and the integral of 2 cos x is the same thing as 2 integral of cos x, which is the same thing as 2 sine x. Okay, now but let's say I want to integrate sine x upon cos squared x dx. To do this, I need to use the method of substitution. I need to say let u be equals to cos x. If u is equal to cos x, I am hoping that by the time I differentiate and I make dx the solution of formula, it will cancel out the sign at the top and it will become simpler. So if u is equal to cos x, it is the same thing as cos x equal to u, which means that if I differentiate cos x, I will have minus sine x, and then I attach dx to it. If I differentiate u, I will have 1, and then I attach du to it. It means that dx is equal to du over minus sine x. So back to the integral, I will have sine x over cos squared x, no more cos, it is now u, so u squared, then dx, no more dx, it is now du upon minus sine x, since we already have it as the subject of the formula right here. So I can cancel out sine x on both sides, okay, so that I'll be left with the integral of negative du upon u squared. The negative sign is from this part, okay, don't forget. Now if I integrate 1 over u squared du negative, it is the same thing as the integral of negative u raised to power minus 2 du, and of course that's the same thing as u raised to power minus 2 plus 1, which is minus 1, over minus 2 plus 1, which is minus 1. Okay, so negative sign can cancel out with this negative sign, so that I can have u raised to power minus 1 plus c, or 1 over u. But remember that u is cos, so finally I will have 1 over what? Cos x, because u is actually equal to what? Cos x. So the final answer for this particular question is 1 over cos x, then plus the other answer is 2 sine x, 2 sine x plus c. Yes, so share these videos with your friends if it has been helpful to you. All right.